Okay, today we're looking at Lesson 8, which is the second part of Section 6 in your textbook. So Lesson 7 had Part 1, you were solving absolute value equations, and now in Part 2, or Lesson 8, we're solving absolute value inequalities. Okay, so as usual, you should have your notebook with you, ready to take notes, do examples, and work along with me. And remember, I go faster in the video than I would in person, so feel free to stop and rewind the video whenever you need to. The biggest thing to remember is that when we're solving absolute value inequalities, you're going to follow the exact same steps as you did in Lesson 7. So you're going to solve them just like you solve absolute value equations, except when you make the second inequality, you're going to flip the symbol around and the sign. So before, you just made one equation equal to the positive and one equal to the negative. But now when you do that, when you make your second one with the negative, you flip the symbol around, okay? Another important thing to remember when we're solving inequalities is that you must flip the symbol when you multiply or divide both sides by a negative. So that's nothing new. We talked about that when we were solving inequalities back in Lesson 5 and 6, I believe. So when you multiply or divide both sides by a negative, flip that symbol. Another thing we need to note here is that we're really solving compound inequalities here. Before, we talked about compound inequalities as two distinct inequalities that come together to make a new inequality. We solve them together, we graph them together, the solutions are together on the number line. So we're doing the same thing here. When we talked about solving absolute value equations, we made two equations. Well, now we're making two inequalities. So they're compound inequalities. And so your answers to the absolute value inequalities, they should be or compound inequalities or and compound inequalities. And you know that your answers or your solutions will look different. If it's or, you're going to have this inequality or that inequality. And when you graph them on the number line, the arrows should go out to the ends. And is a little bit different. You have this inequality and another inequality. You can squish those together to make one inequality solution. And then when you graph them on a number line, the lines or the shading intersects in the middle. So we're going to have to look at those different ways to look at our answers. And you're also going to have to put your answers in interval notation. So you've got to think back to your compound inequalities that we talked about, that interval notation. So with the brackets and the parentheses and the infinity symbols, we're going to be talking about that again. So you may need to flip back in your notes as we go. And if you do, that's perfectly fine. Okay, so we're going to do some examples together. I know that you guys know how to solve. You know how to do a one-step, two-step, multi-step equation and inequality. So with our absolute value ones, we're really focused on making our two inequalities, getting our answers, and representing our answers in a particular way. Now, in your Math Excel work, some of your problems are just going to ask for the inequality, some are going to ask for the inequality and the graph, and then some of them are just going to ask for the interval notation and maybe the graph as well. So we're going to look at our answers all of the different ways, but just know when you do your homework, you won't have to do all ways every single question. Okay, so number one, let's think about our steps from Lesson 7. First, you get rid of any operations outside of the bars. So if you look outside of the bars, do we have any operations? No. So we can go straight to step number 2, make two inequalities. So we take off the bars and we write down the first inequality as we see it, x is greater than 4. The other one, we're going to flip the symbol, so it's going to be less than and a negative 4. Okay? Now, there's nothing left for us to solve, so those are our solutions. But let's think about it. Is it and or? So if you go back up to our little notes, our original symbol is greater than, so this is an or compound inequality. X is greater than 4 or less than negative 4. So we can also put that on a number line. Negative 4 and 4. On negative 4, it's an open circle to the left because it's smaller. greater than 4, open circle to the right because it's greater. And our number line confirms this is an OR compound inequality because our shading is going out to the ends. Okay, number 2 has just a little bit more. There are no operations on the outside, so we're going to go straight to 2 inequalities. So x plus 8 is less than or equal to 9, and x plus 8 is greater than or equal to negative 9. Okay, so solve each of those. They're both one-step inequalities. You guys should be able to do that pretty easily. So we have x is less than or equal to 1, and x is greater than or equal to negative 17. Okay, now we need to decide if it's and or. So our original is less than, so we look up, it turns to an and. So you can write it this way, this inequality and this inequality, but we know from previous compound inequality work, that's not how we're going to see our answer in Math Excel. So you're going to have to squish it together to make one inequality answer. And there are a couple different ways to do that. You can go ahead and put the x in the middle, smaller number on the left, bigger number on the right. Or you can graph it first, whichever one is best for you. Now, if you do decide to graph it first, I think in Math Excel, it makes you type in the answer before it shows you the graph. You can always sketch out a graph on a piece of paper and then figure out your answer that way. Okay, so I'm going to put x in the middle because it's and. We know that the smaller number is negative 17, the bigger number is 1. So 1 is less than or equal to 1, and it's bigger than or equal to negative 17. But as we write it, make sure your arrow points at 17. So remember, when you put them together, the arrow has to point at the same thing. So it points at it points at the x, points it to the negative 17. All right, now on our graph, we have a negative 17, we have a positive 1. We have a closed circle on negative 17, a closed circle on 1, and our lines touch in the middle. And again, you could sketch this out on paper and then figure out your answer from that, okay? But those are the 2 parts of your solution. And I forgot to box in the graph for number 1, okay? So I forgot. Forgive me. I forgot interval notation. I said we were going to do it with all the problems, and it just went right out of my head. So let's go back and do that really quick because you are going to have to include the interval notation on a lot of your answers. So let's go back and look. So at number 1, so if we look at our arrow over here, this is negative infinity. So negative infinity. And what symbol do we always put with infinity? Parentheses. All right, and we go to negative 4. Now, is that negative 4 included or not? It's not, so we use parentheses. If it's or, we use that big U for union to stick them together. On the other side, we have a 4. It's not included because there's no equal to. And we're going to positive infinity, which also has a set of parentheses. So that's the other part of our answer. Okay, again, some of your problems will ask for interval notation, some of them will not. Now, let's go back to number 2. I apologize. So this is an and, so we know we're just going to have one interval. It's these solutions in the middle. So we go from negative 17. Is negative 17 included? It is, and I forgot to color in the circle. So it has an equal sign, so it's included, and we use a bracket. We go to 1. It's also equal to, it's included. So we have a 1, and we have a bracket. Okay? So 3 parts to an answer. Again, in Math Excel, you won't need all 3 every single time, but you can have inequality, a graph, and an interval. Okay, so intervals, you have 2 with a U in the middle. If it's an and, you've got 1 little interval. Okay, now let's look at example number 3, and hopefully I'll remember to do all 3 parts of the answer for you. If we were in person, it would be a lot easier for me to remember because you guys would probably remind me. So just forgive me here as we work through the recording. All right, so number 3, we have the absolute value of the quantity 6x minus 3, and then plus 3 is greater than 18. So step 1, look on the outside of the bars. Are there any operations? Yes. We have a positive 3. How do we get rid of it? Subtract 3. So we have the absolute value of 6x minus 3 is greater than 15. Now, there's nothing outside the bars. Make two inequalities. 6x minus 3 is greater than 15. 6x minus 3 is less than negative 15. Okay, solve each of those. We will add 3 to both sides. 6x is greater than 18. Divide by 6, and we get x is greater than 3. On the other one, we're going to add 3, and we get 6x is less than negative 12. Divide by 6, and we get x is less than negative 2. So again, we have to know if this is an or an and. If it's or, we can stop and graph. If it's an and, we've got to put our inequalities together and then graph. Okay? So our original problem was greater than. So greater than turns to or. So it is greater than 3 or less than negative 2. Okay? So we've got that. Now we can just graph it. So on the number line, we need a negative 2. We need a positive 3. On negative 2, it's open and to the left. And 3, it's open and to the right. Now let's make our interval notation. I'm not forgetting this time. So if you look on this side of the graph, it's from negative infinity to negative 2. So negative infinity to negative 2. Negative infinity always has parentheses. 2 is open, so parentheses. Remember, it's or, so we have to have the U for union. We're going from 3 to positive infinity. Again, 3 is open, so parentheses. Infinity always has parentheses. So again, there are the 3 parts of your solution. Okay, here's example number 4. It looks a little bit different because we've got some distributive property inside the bars, but we can talk about a couple different ways to approach this. So, first thing you can do is you can look outside the bar, see if there are any operations out there. There aren't, so you know that you're not going to have to do anything before you make the two inequalities. Now, for this, if you want to, you can simplify the inside of the bars. You can do your distributive property, combine like terms, and then make two. You can make two and then simplify it all. However you want to do it, whatever seems easiest to you. Now, just because I want to follow the steps, I will make the two and then simplify. But again, it's actually probably going to be quicker to simplify and then make two. Okay, so following the steps, take away the bars, and we've got 4 times the quantity x minus 1 plus 6 is less than or equal to 2. And then 4 times the quantity x minus 1 plus 6 is greater than or equal to negative 2. All right? And just because, like, you might notice as I wrote those down, I'm like in my head as I was writing it down, I know that I'm going to simplify those. And so again, it's probably going to be quicker to simplify and then split them up. And it should work the exact same way. All right, so solve the one on the left. Okay, and I'm going to stop there and go ahead and do this other side just because I want to show you something. Okay, so when I was simplifying, I got the exact same thing. So really, I just did this extra work for no reason. Okay, and I wanted you to see that. I wanted you to see that if I simplify it on this side, then I can really skip to the simplification on this side too. As long as I'm not solving anything yet, you should have the same thing on the left side of the inequality symbol. So again, you can simplify and then split them up. You can split them up and simplify both. You can split them up, simplify one, and see what it should be on the other. Lots of different ways to do that, okay? So whatever way is best for you. All right, let me solve this one on the left. We're going to subtract 2 and get 4x is less than or equal to 0. So x is less than or equal to 0. On the other one, I will subtract 2 and get 4x is greater than or equal to negative 4. Divide by 4, and I get x is greater than or equal to negative 4. Now, I have to decide, is this and or? So look back at the little notes we wrote. This is less than, so less than is and. So I'm going to put and there. And because it's and, I know that I'm going to have to squish these inequalities together. I'll put x in the middle. X is smaller than or equal to 0, but it's bigger than or equal to -4. So -4 goes on this other side, and the arrow points at -4. Then I can put that on a number line. And again, if it's easier for you, you can make the number line first. We have closed circles on both. Our solutions are in the middle. Then we can make our interval notation. Or you could have made your interval notation up here, however you want to do it. Okay, so we're going from -4 to 0. All right, both of them are equal to, so both of them are closed. So that is your interval notation. Okay, I want you to take a look at example number 5. There's something a little bit different about this one that would have raised a red flag when we were doing our absolute value equations. Can you see what it is? It's this negative number over on the right side. When we were doing equations, we knew that the absolute value could not equal a negative. But let's look. What operation is on the outside of our absolute value bars? Minus 15. So we can get rid of that by adding 15. We have the absolute value of 4x plus 2 is less than or equal to 10. Now, that's normal. It should work. So I want you to take just a second, pause the video, create 2 separate inequalities, and see what answers you get. Okay, so hopefully you've had a chance to try these on your own. I'm not going to work out the whole problem for you this time. I'm just going to give you the solutions that you should have. You should have x is less than, I was looking at the wrong thing. X is less than or equal to 2. And x is greater than or equal to -3. Okay, sorry about that. I was getting my notes mixed up. All right, so it's an and. Your inequality gets squished together. X is in the middle. It's less than or equal to 2. And -3 is less than or equal to x. Interval notation, we're going from -3 to 2. They're equal signs. Those are both included. So you put the brackets, and you can graph it on the number line. All right, they both have a closed circle, and your solutions meet in the middle. Okay. Okay, number 6 is just a little bit different. Again, look at it. There's something a little different. It's that negative number on the right side of the inequality. And so let's think about this. Before we try to solve anything, let's just think about it. Think about what we've got here. The absolute value of this quantity is greater than or equal to -7. Okay? When we take the absolute value of something, do we get a positive or a negative? A positive, because it's the distance. So this is a distance. So this is going to be some, no matter what number we plug in, we're going to get some positive number. And then we have greater than or equal to -7. Is a positive number greater than or equal to -7? Yes. You can throw in any positive number and this statement will be true. You could say 100 is greater than or equal to -7. You could say 3 is greater than or equal to -7. Any number that you plug in for x, it's going to work. So this is infinite solutions, or all real numbers. And if you were going to put that in interval notation, you'd have negative infinity to positive infinity. And on your number line, it would just be arrows everywhere. Arrows are shading everywhere. Okay? The opposite of that would be, let's say I have the absolute value of 3x minus 2 is less than or equal to -8. Okay? Absolute value of whatever quantity this is will be a positive number. And so that says a positive number is less than or equal to -8. Is a positive number ever smaller than -8? Ever? No, that's not possible. So you would say no solution, and you wouldn't have an interval. It would be an empty set. You could do set notation. Could be empty set, say no solution, lots of different options. And your number line would just be blank. There would not be any shading, no arrows, anything like that. Okay, so you might have some answers like this in your Math Excel work, so just keep an eye out. Make sure you look and make sure that it's going to make sense. If you've got that negative number over on the right side, first, see if it's going to turn to positive with an operation. Then think about it. Is it going to be a true statement or a false statement? Okay, so again, do your work in Math Excel for Lesson 8. If you have questions, concerns, comments, please, please, please make sure you let me know. And have a great day.